Alright, this video we're going to talk about complex numbers because I'm learning about them recently and I think they're pretty cool. And um, I don't know, I think a lot of people learn them in like middle school or high school and don't really pay much attention to them, or at least I didn't, because it just seems so weird. And you're like, well, I'll probably never need this again. But um, so now I'm doing some differential equations and probability theory and like integral transforms, and a lot of those actually use complex numbers. And so now that I'm doing those, it's like, oh, well, dang, uh, it would have been nice if I actually learned them originally. So I'm kind of going back through now and learning them, and I really like them. I'm very interested in them. So I'm just gonna take you through, I'm gonna try to take you through most things and to do with complex numbers and um, really explain them. But I think in this first video, I'll I'll just go for the motivation and just why they're important. And at the beginning, it might seem sort of basic, but bear with me. I think this will be a pretty quick video, but it'll be helpful. So first of all, let's start with what we're just kind of talking about numbers here because our goal is complex numbers. So we'll start with simpler ones. So if we want to, I knew that would happen. If we want to add and subtract, then all we need are the integers. And then if we want to multiply and divide, then we're using the rationals. And a lot of people call the integers, they'll give it an I, and they'll call the rationals a Q. So that's just kind of notation. But yeah, so that's very basic stuff, but just kind of wanted to let that groundwork go. And then the next thing that's pretty easy is, multiplication is repeated addition, and if we're going to do repeated multiplication, that's exponentiation. Um, and so in its most basic form, just exponentiation as repeated multiplication is just not even the integers, it's just the natural numbers, right? So if we can have q to the n, right? So for example, if we have like 2/3 to the second power is just 2/3 times 2/3, which is just 4/9. And so that should be pretty straightforward. Um, and from there, we're going to get into some more interesting things um, and maybe a little bit more complicated, but I just kind of wanted to lay that groundwork. And again, on this next little bit here, I'm going to explain where we are. So we're comfortable with q to the n at this point. So rational numbers to the natural number power, and that's just repeated multiplication. So then if we're trying to solve algebraic equations, lots of times we'll run into something like this. So what if we have 3/2 to the second power times x is equal to 4? So we want x by itself, and so somehow we want to multiply by the inverse, or the inverse of this. We'll multiply both sides of the equation by that, so we have 1 here times x, and then we'll have x isolated, right? So um, what do we know? We know that what we can do is if we have, let me see here. Again, we're trying to get x isolated, so what we can do is we can say, well, we have 3/2 times 3/2 times x is equal to 4. Well, what we could do is just divide by 3/2, and then, of course, that's over here as well. I'm going to go ahead and take the time to write it just so it's straightforward, right? Um, and so what this is it's the same thing, right? So that's the same thing as, um, oh, that's pretty funny. This guy might pop up again. So 3/2 squared and actually divided by 3/2 squared, right? Um, and one other thing we know about exponentiation is if we have like 2 squared times 2 to the third, that's equal to 2 to the fifth, right? Because you can add the exponents, so it's the same thing as 2 times 2 times 2 times 2 times 2, which is equal to 2 to the fifth. So what we want to do is, and we know something to the 0th power gives us 1, and that's what we want. So really what we want is, our goal is 3/2 to the 0. And if we have 3/2 squared. So that means what we want to multiply by is 3 halves to the negative 2. And this right here, because when these add, they get 0. This right here is the same thing as this bottom part, right? Or at least 1 over that. So what this is just my kind of roundabout or explanation way of saying that I'm going to erase this, go all the way around, is that, I don't know, is that going to let me do this? Delete. Let's try again here. Yeah, second tries a charm is what they say, isn't it? Okay. All right, there we go. So now we know that, um, basically we know like q to the negative naturals. We understand those now is the same thing as 1 over q to the naturals. So what this means is that we now understand q to the integers, right? Because the negative naturals are the integers. So I'm going to go ahead and erase this stuff too, because we are now one step further. We know rationals to the positive and negative integers. So now we are at q to the I power, right? So let me check my notes real quick. Okay, so the next thing we want to do is let's say we have an equation like x squared to the fourth. And we want to isolate x. We want to solve for that. So what we want to do is we want to undo this exponentiation because there's nothing we can like multiply by to undo it. What we have to do is undo this. Yeah, that's the only way to isolate x. So, and another thing we know is, so in just the last slide uh, we said like 2 squared times 2 to the third is equal to 2 to the fifth. There's one other exponent rule that's 2 squared to the third is equal to 2 to the sixth, right? Because this is 2 times 2, and that's 3 times, so 2 times 2 times 2 times 2, so 2 to the sixth. So we're going to use this rule on this part. So what we want to do is we want x to the first is equal to something, right? That's the way to isolate. So what we want is x squared to some power. I did it to myself. I was trying not to. Is equal to 4 to the some power. That's a question mark. So I'm going to go ahead and erase this because that question mark and this question mark aren't the same. So now we have x squared times the question mark is equal to 4 to the question mark. And what we wanted, we set up here is we want this to be 1. So 2 times question mark is equal to 1. Therefore, the question mark is equal to 1/2. So what I'm saying here is the way to undo a squared is to put it to the 1/2. And that's what you've seen before. That's where square roots come from, right? So so now we have broken one more level. Instead of just q to the I, what we have is we have q to the q, right? Because this is a rational number, right? So we are almost at the end of this video too. And then we'll, make another one and go a little bit further. But for now, whoops, I want to get rid of that too. Now we're at q to the q. And I pretty much just want to leave this video by saying we kind of have run into a problem. Because let's say now we have x squared. Let's try to solve this equation. X squared is equal to 2. So we said you undo it by saying x to the 2, 1/2 is equal to 2 to the 1/2, right? Which is x is equal to the 2 to the 1/2. So what this is saying is what number squared gives us 2? And you can try it if you want, but there's no rational number that does this. This is kind of beyond my area of expertise, but basically this is an irrational number and it's square root of 2. It's irrational. So we've passed through the rationals and now we're into irrationals or reals. And I said that as if these are interchangeable. I honestly don't even know if they are interchangeable, but now we are past the rationals and we're into this domain. So that's one thing. And then there's one more piece, is that when we use rational exponents, we run into, what if you put -1 to the 1/2? Or if you have -1, um, x squared is equal to -1/2, right? Because then you would do the same thing. You have x squared 1/2 is equal to -1 to the 1/2. Thus, you have x is equal to -1 1/2. So what this is saying is, what number squared it gives you -1, and that doesn't exist. And this is the motivation for complex numbers, is you're going to run into this problem with exponentiation. So that's kind of where I want to leave this video, is to say we have this problem, and we have x is equal to square root of 2. We have this problem, and this is solved with just real numbers, at least I think. But this problem, we need complex numbers to solve. And we'll go into much more detail in another video, but that's where I want to stop for now.